Hello, my name is RBrock, and I'd like to thank you for joining me in my presentation about the chi-square test for independence results. The agenda for this presentation is as follows. We will first begin with the explanation of a chi-square test. Then we will discuss the results of the test, in which the test with the significant result will be addressed. The following slide has the takeaways from the test. And lastly, I will open the floor for discussions, feedback, and any other questions that you may have. So what is a chi-square test of independence? As directly quoted from Statistical Solutions, a chi-square test of independence is used to determine if there is a significant relationship between two nominal variables. So now that you have a general understanding of what I'm trying to accomplish with such tests, let us begin. The first chi-square test. The following correlation test was conducted. The null hypothesis was there is no relationship between number of cars and number of defaults. The alternative hypothesis was there is a relationship between number of cars and number of defaults. The chi-squared statistic and its p-value were calculated using PSPP, assuming alpha was 0.05. Based off of this, no relationship emerged. Chi-squared equaled 6.68 and p equaled 0.15. The second chi-square test. The following correlation test was conducted. The null hypothesis was there is no relationship between light comfort and number of defaults. The alternative hypothesis was there is a relationship between light comfort and number of defaults. The chi-square statistic and its p-value were calculated using PSPP, assuming alpha equaled 0.05. Based off of this, there was no relationship that emerged. The chi-square equaled 6.68 and the p-value equaled 0.351. The third chi-square test. The following correlation test was conducted. There is no relationship between number of cars and light comfort. The alternative hypothesis was there is a relationship between number of cars and light comfort. The chi-square statistic and its p-value were calculated using PSPP, assuming alpha equaled 0.05. Based off of this, a relationship did emerge, with the chi-square equaling 450, the p-value equaling 0, and Kramer's V equaling 1. Because of this, Kramer's V indicated a very strong relationship. So now that we have found the test with a significant correlation, I will now discuss the key takeaways from this. The first one is the Kramer's V. Within the realm of statistics, a Kramer's V is utilized as a method for calculating the correlation of a table by looking at the rows and columns. The second takeaway, the chi-square test. As mentioned earlier on in the presentation, a chi-square test of independence is used to determine if there is a significant relationship between two nominal variables. The third takeaway, practice makes perfect. As I first begun conducting the test from last week and even now, I found that the more I conducted the test, the more I understood the formula. The fourth takeaway, measure twice, cut once. Another lesson learned that I would like to share is that if you input the data, make sure you are in fact putting it in the right spot. I cannot tell you how many times I personally messed up the results due to me putting the numbers in the wrong row. This adds even more frustration when there is spreadsheets that have compiled data flowing throughout it. So just take your time and ensure you are accurately illustrating the content. And the last takeaway, never assume anything. As it has been mentioned before in our discussions, I will mention it again. The test may be exhaustive, but the data is disjointed. So just because we receive a result with two pair of variables doesn't mean that we'll receive the same result with two other pair of variables that are alike in nature. So this concludes my presentation, and at this time, I will open the floor for any questions you may have. I would like to thank you for your time and hope you have a great rest of your day.